So this is the video on negative exponents. It'll probably be a shorter one, but that's fine. What we're going to discuss is how these work. So let's first talk about a regular exponent. We have a regular exponent. It looks like this. Now 2 to the 4, we're going to do the math. It's 2 times 2 times 2 times 2. So let's see, this is 4, 8, 16. So we know that 2 to the 4th is 16. Alright, now, this is this. That's what a regular exponent does. Now let's talk about a negative exponent. First off, it's important to realize where negative exponents come from. If we have an exponent that's 5 here and 4 here, it's important to remember our mathematics. The law of quotients states that we would take this, make this x, 4 minus 5, top minus the bottom, and we're left with x minus 1. This is where we get negative exponents from. Now this also looks like this. So a way to look at it is we have 1, 2. These x's are crossing out now. It's division, so we can cross out whatever x's we have. So we're left with, we had 4 x's on top that crossed out with 4 x's on bottom. This is how you would write this problem out and do this math. We are left with 1 over x, or x to the negative 1. See how both of these answers produce the same thing? If we have anything, say 2 to the negative 1, it becomes 1 half. Now, it gets a little more confusing when we use higher level exponents. If this makes sense, let's go over this one more time. X to the 4th minus 5, because that's our quotient rule. And that's where we get negative exponents from. But why negative exponents go on the bottom is because of this. It's because we're left with something on the bottom. So in order to get rid of a negative exponent, we have to move it either to the top or the bottom, depending on where it's at. And we'll discuss that more in a minute again. This is the reason why negative exponents produce a fraction. Because we end up with more on the bottom than on the top. Because we get 4 minus 5 gives us x to the negative 1. 4 over 5, cross out all those things, leaves us 1 on the bottom, and that can give us x to the negative 1. That is why this works, and let's discuss that. So if we're going to talk about this 2 to the negative 4th, we have technically 1 over, because that's the negative part, right? The negative part says we're going to go 1 over. Now this 4 still is there. So we left with 2 to the 4. And then that equals 1 over 16. So that exponent travels down with it. This is technically 2 to the 1. That negative 1 comes down. This is technically x to the 1. So we can produce things like that because we know the law of exponents. Now what if we had 1 over 2 to the negative 4, because we see that occasionally? Well, we would do the same thing. It would just be 2 over 4. We take this and move it to the top to get rid of that exponent, the negative. Got rid of the negative, it became 2 over 4. So that's something to keep in mind when doing these problems. Let me show you another example, and we'll hit this pretty hard. We have something like this. All right, now we have 2 negatives. We need to remove them. to make this better. We don't like negatives in our exponents if we can remove them, and we can because we have a division line. Alright, now we're going to say, well, we can't subtract them because x is not the same as y. In order to do our other rules, we need the same base. Negative rules don't need the same base. We can use those whenever. Our other rules do require the same base. The negative rules don't. So what we're going to do is we're going to produce a y5 because this y goes to the top. The negative goes away, and we're left with just y to the 5th. Now this x will go to the bottom. The negative will go away. We're left with x to the 4th. So this applies when you have big problems like z to the negative 5th, x to the negative 10, y to the negative 6, over z, or over w to the 5, 3 to the 2, and p to the negative 3. So we're going to simplify this. And how I usually do it is I start on the top and move everything down that needs to go down. So I say, okay, well, z to the 5th. That needs to go down because it's negative. X to the 10th. So this is the bottom of our fraction bar. X to the 10th has to go down because it's negative. Then y to the 6th has to go down because it's negative. It doesn't matter what order we put this in because multiplication is cumulative, which means that it adds up as we go and it doesn't matter the order. So that's why we can put them in any order we want and it works out fine. Also, now we have, then I go to the bottom and I say w to the 5 because it's positive, 3 to the 2 which is 9, and then p to the negative 3, so that's going to come up to the top. So that's how this rule applies. It applies in ways like this, where we see it's growing, but each individual number is affected without affecting the numbers around it. We can pull p to the top without affecting w, 3, z, or x because it's not added or subtracted, it's multiplied. We can pull p to the top without affecting w or 9 because it's multiplied. Multiplication can be separated like that by division. And that's what we're doing, is separating it by division. And that's why you see this. Now the reason that the one on the bottom goes to the top, we can discuss that real quick, is this. When you have 1 over, let's just say x to the 1, to the negative 1, it looks like this. It becomes 1 over x. Now that's confusing, but it's not that bad. We just know our properties of fractions. We have 1 over 1 divided by 1 over x. When we have that in a fraction, we just reciprocate and multiply. 1 over 1 times x over 1, which just gives us x over 1, or x. That's why we can remove this. The same principle applies with x to the negative 2. No matter what we have on top, I'll show you. If we have 3 on top of x to the negative 2, that becomes 3 over 1 over x squared, which is equal to 3 over 1 times, or divided by 1 over x, which is the same as 3 over 1 times 1 over x multiplied, and then when we multiply across, x over 1, it produces a 3x And if you remember, our squared came with us the whole way. So you get 3x squared. So I hope this helps in understanding a little bit about why exponents do what they do when they're negative. If you just keep watching this video over and over again until you get the concepts. This video was very concept heavy on just that one subject. So I'm hoping that that'll help you out. And then you'll be able to understand that. There you go.